Good morning. Good morning, everyone. Am I audible? Good morning, Ishan. Good morning, Adam. How are you all? I hope everyone is good. I'm good too. So, has everyone solved problems of FPO question number 4 to 40? Has everyone solved it? Does anyone have any doubts in the booklet? Viroke has a doubt in question number 25. Any other doubt? Any other doubt? Anyone? We have a doubt in question number 25. Does anyone else have any doubt in any other question? Okay, then let us solve the question number 25. The number of electrons in 2 gram ions of nitrate is 2 moles of NO3 minus ion, or total 2 Na ions of NO3 minus. Total number of ions are 2 Na. Let us find out number of electrons in 1 NO3. Number of electrons in 1 NO3 minus ion. It has 1 nitrogen atom. Nitrogen atom has 7 electrons. It has 3 oxygen atoms. Each oxygen atom has 8 electrons. It has a negative charge, -1, so 1 extra electron. Total number of electrons will be 7 plus 24, 31 plus 1, 32. Total of 32 electrons. The number of electrons in 1 nitrate is 32, and we have total number of nitrate ions as 2 Na. The total number of electrons will be number of nitrate ions into electrons per nitrate ion. This comes out to be 64 Na. Anya, you cannot hear me. Can others hear me? Am I audible? Others can hear me. Anya Porwal. Okay, little faint. Let me increase the volumes. 1 second. But it's clear now. We're okay. Whoever is finding a problem in listening, please adjust your audio device. Okay, it's working fine. Most of the people are able to hear me. Okay, the voice may be a bit low, but it should be clear. So increase your volumes to maximum. One second. Hmm. Is it okay? Clear with okay? Okay. Let us do question number 40 next. Somebody had a doubt in question number 40. Keshav had a doubt. Let me do question number 40. One. How many moles of magnesium phosphate will contain 0.25 mole of oxygen atom? How many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? Not a difficult question, not very difficult. Let us assume that moles of magnesium phosphate, इसके moles assume कर लो n. So moles of oxygen will be atomicity of oxygen. What is the atomicity of oxygen here? 8 into moles of the substance, that is n. And it is given that moles of oxygen is 0.25. This is equal to 8n. N is equal to 0.25 by 8. So 25 by 8 into 10 raised to 9. 3.1. Clear है ये? Is this clear? Any other doubt? Any other doubt? Okay, fine. Let us continue. The last lecture we talked about molar mass of mixture of gases and vapor density of mixture. Okay. Let us continue with today's lecture. One second. Let us do laws of chemical combination. Laws of chemical combination. The first law which we'll discuss is the law of conservation of mass. The statement says that the total mass remains conserved, remains constant in a chemical reaction. In other words, the mass of reactants consumed is always equal to the mass of products formed. Mass of reactants consumed is equal to the mass of products formed. Total mass does not change. Okay. It also implies that atoms are conserved in a chemical reaction. Number of atoms of any element reacted is equal to the number of atoms of that element produced. Okay. Atoms retain their identity in a chemical reaction. No existing atom is destroyed, no new atom is produced. So that we can write this point. The atoms are also conserved in a chemical reaction. No new atom is found. No existing atom is destroyed. Do we have any exceptions to this law? Are there any exceptions? Nuclear reactions are exceptions. Yes, very true. Exception to this law are nuclear reactions. In nuclear reactions, some mass is lost, which gets converted to energy. Okay, the nuclear reactions are exceptions to the law of conservation. Nuclear reactions also result in both nuclear fission as well as fusion reactions are exceptions. Any kind of radioactive decay is also a nuclear reaction. And in a nuclear reaction, atoms lose their identity. Some new atoms are produced, some existing atoms are destroyed. So we can say that the law of conservation of mass is not followed in nuclear reactions. Clear है ये? Is this clear? Now let us do a simple question, okay, which shows an application of law of conservation of mass. Question for 6 grams of a hydrocarbon on complete combustion gives 17.6 grams of CO2 and 10.8 grams of H2O. Show that the data is in accordance with the law of conservation of mass. Let me do it for you. Let me solve this question for you. You have to show that the data is in accordance with the law of conservation of mass. You can say that total mass of carbon and hydrogen in the reactants will be equal to the total mass of carbon and hydrogen in products. Okay. So in product, carbon is present in CO2 and hydrogen is present in H2O. So let us find out moles of CO2 first. Moles of CO2 is mass of CO2 upon molar mass. Mass is given as 17.6, molar mass is 44. This is 0.4. Okay. Moles of carbon will be equal to moles of CO2 क्योंकि कार्बन की एटॉमिसिटी 1 है, equal to 0.4. Mass of carbon will be moles into gram atomic mass of carbon. The mass of carbon in the products is 4.8 grams. Similarly, we'll find out moles of H2O. Moles of H2O will be mass upon molar mass 10.8 upon 18 is 0.6 moles. Moles of H will be 2 into moles of H2O because atomicity of hydrogen is 2. 2 into 0.6 is equal to 1.2. Mass of H, atomic mass of hydrogen is 1 gram, so moles into gram atomic mass, it is 1.2. So mass of carbon in the product is 4.8 grams, mass of hydrogen in the product is 1.2 grams. We have calculated the mass of carbon and hydrogen in the product. We have calculated the mass of carbon and hydrogen in the products. Add it. Total mass of carbon plus hydrogen in the product equal to 4.8 plus 1.2 is equal to 6 grams. And this is equal to the mass of hydrocarbon reacted. 6 gram react रहा था ना मैंने hydrocarbon. So this shows that the masses are conserved. Okay. The mass of carbon remains conserved, mass of hydrogen remains conserved, mass of every element remains conserved in a chemical reaction. Okay. The data is definitely in accordance with the law of conservation of mass. Clear है ये? Understood everyone? Turn करूं? So mass of carbon plus hydrogen in the product is equal to mass of hydrocarbon reacted. Hence prove. Hence, the data is in accordance with law of conservation of mass. ठीक है? Next, we'll continue with the laws of chemical combination. The laws of chemical combination. Second law will do law of constant proportions. Okay, पहले मैं स्टेटमेंट लिखाता हूँ फिर एक्सप्लेन करूंगा. स्टेटमेंट लिखो. When two elements combine with each other to form two or more compounds, when two elements combine with each other to form two or more compounds, then the different masses of one element then the different masses of one element that combines with a fixed mass of the other element are in simple number ratio. When two elements combine with each other to form two or more compounds, then the different masses of one element that combine with a fixed mass of the other element are in a simple whole number ratio. This ratio is equal to the ratio of valencies of the other element. ठीक है, ये नोट कर लो. स्टेटमेंट एग्जांपल से इलस्ट्रेट करता हूँ. Let's take an example of carbon and oxygen that combine to form carbon monoxide and carbon dioxide. Two elements combining to form two or more than two compounds. The two compounds here are carbon monoxide and carbon dioxide. In carbon monoxide, valency of carbon is 2. This is combining with only one oxygen. Oxygen is divalent. The carbon will also be divalent. In carbon dioxide, valency of CO2, sorry, valency of carbon is 4. The ratio of valencies is equal to 2:4 is equal to 1:2. तो रेशियो वैलेंसीज निकाला हमने. अभी मैं ये लॉ एक्सप्लेन करता हूँ. नेक्स्ट पेज में करता हूँ। इतना क्लियर है सबको? Next, let me illustrate this law. So, regular format, let us make our observations. So carbon monoxide has one carbon and one oxygen atom. We can say that 12 grams of carbon combines with 16 grams of oxygen. And in carbon dioxide, we have one atom of carbon and two atoms of oxygen. We can say that 12 grams of carbon combines with 32 grams of oxygen. So we have different masses of oxygen combining with a fixed mass of carbon. Fixed mass of carbon 12 gram, carbon 12 gram. So we can say that the ratio of different masses of oxygen that combine with a fixed mass of carbon is equal to 16:32 is a simple whole number ratio which is equal to 1:2. And this ratio is same as the ratio valencies of carbon. वैलेंसीज का रेशियो कितना आया था 1:2 और ऑक्सीजन के मासेस का रेशियो भी 1:2 आया. Hence, this is the illustration of the law of constant proportions. Actually, एक mistake किया मैंने. This is called law of multiple proportions. This law is called law of multiple proportions. So correction कर लो. Law of constant proportion is little different. This law is called law of multiple proportions. ठीक है, ये correction कर लो. Please do it. It is not the law of constant proportion, it is the law of multiple proportions. Law of constant proportions will be doing. The law of multiple proportions, when two elements combine to form two or more than two compounds. In this case, the two compounds are CO and CO2. Then the different masses of one element that combine with a fixed mass of the other element. The different masses of oxygen that combine with a fixed mass of carbon are in a simple whole number ratio. A different masses का ratio एक simple whole number ratio आएगा, तो 16:32 is 1:2. ठीक है? And this ratio must be equal to the ratio valencies of the other element. So this ratio is equal to ratio valencies of carbon, which we have found out in the previous page. ठीक है? Understood everyone? ये समझा सबको? इसको number 3 भी लिख लो. Number 2 law of constant proportions. Right? It says number 3 law of multiple proportions. Okay. So is this clear? Law of multiple proportions clear to everyone? Very good. Anya, Samja, Astha, is it okay? Keshav, understood now? Soumya, Sayuj, good. Law of constant proportions is easier. So let us now write the law of constant proportions. This is straightforward, pretty straightforward. It states that the mass ratio of different elements, the mass ratio of different elements present in a compound remains constant. The mass ratio of different elements present in a compound remains constant, irrespective of the source of the compound or the method of preparation of the compound. The mass ratio of two elements present in a compound remains constant, irrespective of the source of the compound or method of preparation of the compound. एक second. अब एग्जांपल देखते हैं of constant proportions. Take any compound. Let us consider water. Water formula is chemical formula for water is H2. Two atoms of hydrogen and one atom of oxygen. We find out the ratio of mass of hydrogen to mass of oxygen in water is equal to two atoms of hydrogen, 2 into 1 atom of oxygen, 1 16 equal to 2 by 16 is equal to 1 by 8. The ratio of masses of hydrogen and water. This ratio remains constant irrespective of the source of water. It tap water हो या rain water हो या sea water हो. Okay, water derived from any source, sea water, lake water, tap water, rain water. Anywhere water will have the same mass ratio of hydrogen and oxygen. Water will always contain hydrogen and oxygen in 1:8 mass ratio. So that is what is law of constant proportion. Okay. This is also irrespective of the method of preparation of water. Okay. Water can be obtained in different chemical reactions. It can be obtained in combustion of hydrocarbon. CH4 plus O2 gives CO2 plus H2O. Water can also be obtained by neutralization of acid and base, acid plus base, salt plus water. In whatever reaction water is produced, it will contain hydrogen and oxygen in the same mass ratio, that is 1:8. And this is what is law of constant proportions. Understood, everyone? Turn करूं page. A question देखो based on this. (15.2 grams of a compound X4O6 contains 10.4 grams of X. Find atomic mass of X. Atomic mass of oxygen is 60. 15.2 grams of a compound X4 contains 10.4 grams of X. Find atomic mass. अच्छा, प्रीवियस पेज देखना है, जल्दी से देख लो प्रीवियस पेज. Now do it. Try it once. I'm giving you 2 minutes. $52 is the correct answer. There may be multiple ways to solve this. Okay. I will try and solve this question with the help of the law of constant proportion. Don't get confused. Actually, first law we did was law of conservation of mass. Second law, by mistake, I did the law of multiple proportion. So normally second law we do is the law of constant proportion, and third part is law of multiple proportion. So numbering थोड़ा आगे पीछे हो गया है, ठीक है? Don't get too confused. Numbering doesn't matter actually. Okay? But first is law of conservation of mass, second is law of constant proportion, third is law of multiple proportion. Okay? Now, how to use the law of constant proportion to solve this? You can say that the mass of X upon mass of oxygen in the compound will be a constant. The ratio of masses of X and oxygen will be a constant. Now it is given that 15.2 gram X406 has 10.4 grams X. The remaining will be oxygen. Oxygen कितना आएगा? 15.2 minus 10.4 is equal to 4.8 grams oxygen. The ratio of mass of X to mass of oxygen, the ratio of mass of X to mass of oxygen comes out to be 10.4 by 4.8104 by 48. You can also find out this ratio, this 52 by 24. Okay, we can also find out this ratio from the molecular formula. From the molecular formula, it is clear that it has 4 atoms of X, 4 into atomic mass of X, and 6 atoms of oxygen, that is 6 into 16. This is determined from the formula. This is determined from the data given. Now, the mass ratio should be a constant. It should not change, however we determine it. We'll say that 104 by 4a by 6 into 16 is equal to 104 by 48. We solve it. This is 2 by 3. This is 3 times 3 and 3 cancel. We'll get A is equal to 104 by 2 is equal to. The atomic mass of X is 52. Is this clear? X is any hypothetical element. I'm not talking about any particular actually existing element. Okay? I think atomic number 52 is tellurium. Mass 52 is chromium. But chromium forms Cr2O3 and not Cr4O6. So ठीक है. Question hypothetical हो गया. Fine. It okay? Understood? Understood everyone? So how we have applied law of conservation of mass to solve this? एक और क्वेश्चन देखो. Compound A3B contains 60% by mass of A in it. Find the ratio of atomic masses of A and B. Find the ratio of atomic masses of A and B. One is to two is correct. Very good. Found A3B contains 60% by mass of A ratio of atomic masses of A and B will be 1:2. The correct answer. देखो कैसे use करेंगे? You can say that mass of A upon mass of B is equal to 60 by 40 from the data. 60% of A, the remaining 40% will be B. And mass of A upon mass of B will be 3 into atomic mass of A upon 1 into atomic mass of B. This is from formula. This should be equal to 3A1 upon A2 is equal to 60 by 40 is equal to 3 by 2. A1 by A2 is equal to 1:2. Clear है ये? Let's do some more questions from the booklet. Booklet में get equipped to JEE Advance, attempt question number 3, question number 4 and question number 8. Try करो एक बार. Try these questions. Get equipped to JEE Advance, question number 3, question number 4 and question
हो गया क्वेश्चन नंबर 3, 4 and 8. Have you got the answers? क्वेश्चन नंबर 4 का A, 3 का B. एक सेकंड. You have got answers as 3 का B. Question number 3 is similar. Question number 3 क्या है? 3.6 grams of an oxide of a metal gives 3.2 grams of metal. So 3.6 gram of metal oxide has 3.2 grams metal. So remaining will be oxygen. Remaining 0.4 gram will be oxygen. We can say that mass of metal upon mass of oxygen, the ratio will be 3.2 upon 0.4, that is equal to 8:1. Okay. Atomic weight of metal is 64. The simplest formula of the oxide will be. So let us write the formula of the oxide as MxOy. So from the formula, we'll get mass of metal is to mass of oxygen is equal to 64x upon 16y. There are x atoms of metal and y atoms of oxygen. So from the formula, ratio will be 64x upon 16y. This is equal to 4x by y. And the mass ratio should be equal. So we'll say that 4x by y is equal to 8. So x by y is equal to 2:1. The simplest ratio is 2:1. Formula will be M2O. Formula will be M2O. Answer will be B. देखो, it is given that on reaction with hydrogen, it gives this much metal. तो ये metal तो metal oxide से ही बन रहा है ना, आरव. This metal has been formed from the metal oxide only. That means the metal oxide contained this much amount of metal. What are the other products? That is not relevant here. Other products are not relevant because we have to find out only the simplest formula for the metal oxide. So metal oxide must contain some metal and some oxygen. It had how many grams of metal? It had 3.2 grams of metal. The remaining will be oxygen. Understood? Question number 3. Okay. Question number 4 and question number 8, I'll explain in the 10 AM lecture. Okay. Let us take a break, have our breakfast. Okay. We'll see you again at 10 AM. Okay. Chalo. Thank you, everyone.